again, just kind of as a very, very, very quick review for my folks that are watching and listening at home. We have 3 things that's going to be on the benchmark next week. So we have 1 week until the benchmark that we take for science. And that's going to be force and motion, which we're going to kind of review today. States of matter, which we just finished and should be fresh in our head. And then there's something that we haven't officially taught in class, heat exchange. But I feel like we've covered that pretty thoroughly. When I talk about conduction, convection, and radiation to you, most of you in here know what I'm talking about. At least when I ask questions about radiation, you say the sun and a fire. When I say conduction, you say touching things. I think convection is the one that we're a little bit iffy on. But that's when heat moves through the air or through water. And I'm sure we'll get that as we continue to review throughout the week. But force and motion. So again, we're going all the way back, like way back to pushes and pulls, like when we first started talking about force and motion. We'll get to the tougher stuff about forces and motion today. We'll look at some motion graphs. We'll look at some DST triangle stuff. But this is what we're going to go through for this for right now. That might all be in here. This is a big review. So as I watch this video, I'm going to play it, and you guys are going to have to be paying attention because it's going to ask you, it looks like 3, maybe 4 questions as we go through this. So this should be, and I'm looking at faces in the room, like super sleepy faces that haven't had normal bedtimes in like 2 weeks. Force, you should know all the answers to those, right? Friction, you shouldn't have any struggles with, and we haven't really had any struggles with that. When we watched the video and we answered the questions, we all got them right. When we took the quiz on the last thing, we had like a 78 class average, which means most of us are getting them all right. Gravity, you shouldn't be missing gravity. Gravity is the force that pulls things towards something. Gravity pulls you towards the earth. I would not be shocked, Brandon, if you see that question, what keeps the earth in orbit around the sun and what keeps the moon in orbit around the earth? And the answer to both of those is gravity. And again, we've talked about why the moon isn't pulled all the way towards the earth, because the moon is also trying to travel in a straight line at a very high rate of speed. The earth is also traveling in a straight line, trying to at least, at a very high rate of speed. But the sun is also pulling on it at the same time, and therefore it has that orbit. Here we go, quickly. Does gravity pull the same on all objects? For example, if I dropped a bowling ball and feathers at the same time, is there any way they could hit the ground at the same time, and why? I'll know very quickly if you paid attention in class during this unit. So as I kind of go through this and I look at all the answers, a lot of people are saying that there's no way that they could ever hit the ground at the same time, because you're saying this because the bowling ball has more mass. And that has absolutely nothing to do with it. Gravity pulls the same on everything. But Mr. Bullens, when I drop a bowling ball and feathers at the same time, they don't hit. If I drop at the same time, they don't hit at the same time. That's because friction is acting on the feathers. Feathers do not have as much mass, therefore, as they're falling, and they're also shaped very differently. But again, and it's not if I take all the gravity out of the room. If I take all the gravity out of the room, they both float. If I take all of the air out of the room, all of those molecules of air out of the room, and we watched the video, hopefully I attached that. If not, I'm going to go back and watch it with you really quickly. They would hit at the exact same time. Because air causes friction, and we know that friction slows things down. It has nothing to do with the mass of everything. So let's see if I added that. If not, we're going to go back and watch it for certain. There we go. I'm going to fast forward through a whole bunch of this. All right, friction. You get the lights, man. Friction. We know that friction is something that slows things down. You guys know that. I don't think they're going to throw some crazy question about bowling ball and feathers falling at the same time. The gravity questions are going to be what pulls objects towards the earth. Billy throws the ball, it comes back down. Why? And what keeps the earth in orbit around the sun, or what keeps the moon in orbit around the earth? And those are answers are gravity. Friction will most definitely be on there. I would be absolutely blown away and shocked if you don't see something about something slowing things down, causing heat, why you need oil in an engine, which was a big question that we all struggled with on that one review that we did. and that's friction. We have to talk about friction. So let's get to today's quote-unquote project. I'm going to... All right, so when we did states of matter, I think that this should have given you an even better understanding of mass. And what is mass? Well, mass is how much matter is inside of an object. And when we looked at states of matter, we specifically talked about the molecules inside of something, right? And we know that sometimes it depends on what the object is. But if you take a ping pong ball and you take a golf ball, and if you were able to kind of shrink yourself down and be able to look at all the molecules, like you couldn't walk through the the golf ball, right? Because the molecules are so close together. They're so tightly packed together in that golf ball that moving through those, even if you were super tiny, wouldn't be a very easy thing to do. However, if you shrunk yourself down enough, like if you were Ant-Man or something, which would be super cool if we could do that, PIM particles, shrink ourselves down. Once we got past the outer layer of the ping pong ball, the inside of the ping pong ball is just empty space. It's just air.
I mean, what if you like shrink yourself back down? Like, if
you would be able to see the molecules like we did in that video when we were looking at the water, and we looked at when we mixed sugar and water, and you could see the water, like the sugar molecules and the water molecules kind of hanging out, but they're not joined together or anything.
if we were like that,
Mass, pretty easy, right? I don't think mass is super tough. Now, let's take a look at this super cool pile of rocks. Now, I know that there's some parents out there would probably want to take these rocks and put them around their plants outside or maybe on a walkway or something. I would want to take all those and skip them across a pond because they look pretty smooth. Now, I want to ask a quick question. If I take these little rocks, is there anybody in here that would struggle to move those?
no,
Probably not.
not really.
However,
It would still have mass.
would any of us, like, do you think we could take the entire 5th grade and move this rock? No.
We're gonna need Hercules for that one.
Yeah, we would need a tool to move that. Probably dynamite to break it into smaller bits, and then still construction equipment to pick up those giant chunks of rock to ever get that out of the way. Because look at the size of that compared to this person. Why? Someone describe to me, why am I able to move this little pile of rocks with little to no effort when I can't move this huge rock at all? I am going to stop. This will be the last term that I do in this class. I'll see if I get any further in the last class before I post this video for the day. But inertia, again, still reviewing. Nobody should be jotting any of this down. Inertia is pretty easy because it's the same thing as Newton's first law, right? Inertia. If there's a kickball that's been outside since we left on vacation, it's probably still sitting in the same spot unless the wind moved it during that storm that went through, because that was pretty powerful, right? But an object is not going to move unless a force moves it. And then once it starts moving, it does not like to stop unless something stops it. And what's that one force that we know that slows things down and stops it? Yes, ma'am. Friction. Friction. So I'm going to stop this here.